Okay, where's the chicken? There? Okay, that's right. Okay. Oh, all the way back there. Yeah, okay, I see. Okay. It's compressed a little bit, but it's good. Its aspect ratios are known to find. All right.
Sorry about that.
No. That's a good start. No, you're also supposed to sign one of the numbered lines. Just like yeah, I know. I'm not deploying it in my laptop because I'm just going to sit here. I'm just going to sit here and paste and stuff. I'm sure. Okay, this is now the TSVWG meeting. If that was not your intended destination, the hallway is outside. Okay, in order to get started, need a note taker and a jabber scribe. Can I get a volunteer to take notes for minutes, please? All right. Who do I have to embarrass into helping out with taking brief notes for the minutes? Magnus, you want to do that? All right. Let's go find somebody else to do it. Stuart, can you take brief notes? That's unfortunate. We'll just keep trying here. Ryan, can I ask you to take some brief notes for the minutes, Mr. Carpenter? Yeah, I know that struggle. I had 2 cups of coffee earlier. Brian, was that an okay? You'll try. Was that an okay? You'll try. Thank you. And anybody want to be Jabber? Can I get somebody to be the Jabber scribe? Is anybody actually in the Jabber room? Okay. Thank you, Miria. Okay. Here comes Corey. So this is Transport Area Working Group. I'm David Black. This is Gory Fairhurst quickly scrambling up. Wes could not be here, so the 2 of us get to try to run things. This is the first session. We have an hour today, followed by 2 hours on Friday morning. This is the IETF note. The usual IETF note, well, please pay attention to it. It applies to you, including to any comments made in this meeting. Okay, we've got a note taker, we've got a Jabber scribe. In general, folks, drafts you see on the list, they could always use reviews, and in particular, this is a scratch of the help other people out. If you review other people's drafts that you care about are more likely to get reviewed. All right, time to start doing something useful here. Accomplishments and status. We've had no RFCs published since Prague, but there are 3 in the RFC editor queue, 2 of which are about to emerge. Details and cap of SCTP and the SCTP IData chunk draft are both in Authors 48, and there is work going on between the authors and IETF to pull things out. The third one, the difference of WebRTC QoS, is part of the WebRTC draft tarball or hairball. It's going to be at the RFC editor for a while. There's one ID in post-IETF last call processing. That's my ECN experimentation draft. That's what happened there is we sent -06 to the IESG. -07 resulted from IEC comments. We wound up actually adding a fair amount of text to it. In essence, the most important piece of that is a summary of what other people working with ECN need to understand about this draft and how to stay out of the way of experiments. Bob Briscoe gave that a good, solid review. Bob and I are 80% through his comments, and what that means is four out of his 5 major issues are resolved, plus a bunch of editorial stuff. There should be a -08 appearing tomorrow. With luck, that'll contain the final resolution of Bob's comments, or we'll have one more go around on that.
And heads up, there are changes that have occurred since this left the working group. The IESG has given us lots of review, other people have as well. So there are changes to the wording. If you care about the detailed wording, please read the latest draft. We'll post that to the list before we send it on to the RFC editor.
Right. So in particular, 08 will get posted tomorrow, and if we need more changes, an 09 is not a problem. Okay, that was the first one. Second one, we had a successful IETF last call on the diffserv to Wi-Fi mapping draft. That's in IESG evaluation. I think they're going to make a decision on it at the end of November. And as we'll explain a bit more later in just a little bit in the session, we'd like to get the DiffServ lower effort PHB draft to working group last call fairly soon. There's a crucial decision we have to make today, and we'll talk about that in a minute or two. There are 11 additional working group IDs. Your highly paid chairs regard this as a high watermark, and so we want to move some of these drafts along out of the working group into other people's hands before adopting any more drafts in the working group. Okay, note on a few related drafts. There's a couple of individual submissions that will be discussed here. Transfer header encryption impacts today. Transfer header encryption impacts, is that today or is that Friday? It's on the, both these are on the agenda, and datagram packetization PMTU detection. One of those is today, one of those is Friday. I think transfer encryption is today. There's 3 drafts in the interior working group: tunnel MTU considerations, a multipath library, and SOX protocol version 6, which is now at -01. If you're interested in these, please go to the interior meeting. 2 more related drafts: priority switching scheduler draft, draft FINSI. We're gonna try to bash the agenda in a minute to see if we can get a little bit of time for that in this meeting, and then the deterministic networks folks are starting to think about a transport layer. Draft Thubert is going to, despite its name, is actually going to be discussed in the DetNet meeting this week. We need to have a bunch of transport people show up there, and unfortunately, I think DetNet and TCPM conflict. Okay, this is what the agenda looks like. We're going through note well, Dr. Conference status. Going to do milestone review in a minute. Drafts today. Friday's agenda is note well and a lot more time for drafts. Next thing up is milestone review, and then I'll put up the detailed agenda. Okay, milestone review. So we had a bunch of drafts that we had thought we would get the ISU between now and the end of the year. Those first 5 drafts, the two in what color is it? Orange, yellow. It was orange. And the first 3 in green. We're not going to get all 5 of those drafts to the IESG in the next month or so. Bob, what's a reasonable date for sending those first 2 drafts about ECN encapsulation to working group last call? All right.
Bob, I've just posted one this morning.
Okay, so
which
you
is
think
ready now? But
okay, so you think that draft's a 6040 shim update draft is ready for 64 update shim draft is ready for working group last call?
It's ready. We'd have to not alter Teredo, and I just want to try and persuade Praveen one more time to alter Teredo, because this is a nice window of opportunity to make a small change to something which will take a lot longer if you do it later. So,
all right. Just for grins, let's put January on those 2. If we're earlier, we get extra credit. But I think January. I think January sounds reasonable for the ECN and CAP, the 2 ECN and CAP drafts. One of the things I need to do a careful review of the overall one.
That's the date for working group last call closing.
Yes. So the goal would be to send a working group last call. Goal will be to send a working group last call in December and get into the IESG in January. Well, yeah, it's a that assumes they escape working group last call unscathed. Okay. Michael or Randy, the SCTP drafts.
Probably hear from the SCTP people on Friday when there's SCTP session.
We'll get new milestones for those on Friday. Note, I've got to do that. And we've beaten the LEPHB draft up enough. I'm going to go ahead and move that one. I'm going to go ahead and move that one to January also, for the same reason I put Bob's in January. Okay. Rest of the milestones probably get stay put. Transport options we're hoping is April. The 3 L4, let's see, the 2 FEC drafts in June, the 3 L4S drafts in September, and television feedback draft. Right now, we've pushed out a year. Chairs are a little uncertain about the future of the draft. It needs some major revisions. Okay, with that, let me quick show the agenda as is. This is agenda bashing. We've done document status chart and accomplishments. Next up will be what's probably, I think, a status update from Bob on the 2 EC encapsulation drafts. Lower effort PHB draft round 1 follows. The goal here is we really do need to pick the DSCP, the diff-serve code point, for the lower effort PHB this week. So it's on the agenda twice. Today, I think Gory's going to lead a discussion about making sure we understand what the problem is, what the considerations are, and why this isn't an easy decision. And we're going to try to make a decision on Friday, followed by the transport encryption draft. Now, we're also going to bash the agenda. If time permits, we'd like to give draft FinZ priority scheduler draft 5 minutes at the end of the meeting if we get through everything else before then, and have 5 minutes to spare. Whoops, try going forward. Okay, on Friday, SCTP drafts, L4S drafts, lower effort PHB round 2 to make DSCP selection, the 2 FEC frame drafts, and then the datagram PMTUD draft. And if you're an ICCRG, you heard this draft Han 6-man draft mentioned. It's actually going to get discussed here Friday. Okay, aside from the change to try to fit in the FinZ, draft FinZ scheduler draft into this end of this session, any other agenda bash requests? Hearing none, consider the agenda bashed. Bob, do you have slides, or you just want to talk? Yeah, and they're in my email somewhere. I have no idea.
No, I sent it to Wes, actually, because he was the one who originally asked for it.
Excellent. Well, Wes is in a different
TSV
continent.
chairs. Yeah. Yeah.
Okay.
By URL, not by an attachment.
Yeah.
Do you have a?
I could probably play them off my laptop.
Why don't you play them?
Yeah.
Play them off your laptop. I think we're gonna have to. I think we're gonna have to play musical laptops here. Yes. Yes. I'm running HDMI now.
Okay. So this is Bob's spanking new laptop, which is going to work brilliantly. And we'll other sides the proceedings as Bob gives the talk. And we can facilitate the pressing of buttons.
Yeah. Big box together, and yes, slides. You need eyes back your head to use. Unfortunately, you guys need to put a computer right there.
Right. Okay. So as I said, just posted, updated this morning. Next. Couple of recap slides that are there mainly for those that are not used to what goes on here. So I'll very quickly go over these. Essentially, there are 2 problems. First is that a RFC on tunneling of ECN didn't quite specify its scope precisely enough, and so there was ambiguity whether protocols that have a shim between two IP headers were included in its scope. Second problem was that it didn't address a problem where a tunnel endpoint that wasn't even trying to implement ECN tunneling still had to set the outer ECN to something, because there's 2 bits there, you've got to put something in them. And there's only one safe way of doing that if you don't know what the other end is going to do with them, which is to zero them. So next, those 2 parts of the problem, did a survey of how they deal with, or how various RFCs deal with those 2 things that do ECN tunneling with a shim between them. And the more you look, the more of these you find. This is only those that are standards track or widely deployed, and there's a lot more that are not standards track or not widely deployed, and there's quite a lot of standards track that aren't widely deployed as well. Anyway, no, well, I'm going to have to stay on this one for quite a while. The red ones are the ones that I've updated this cycle, or I've added this cycle. And the reason I'm saying let's stop and do working group last call on this is I think this process is a bit one that has a halting problem, in that it will never halt. And so the main problem, the 2 problems I just talked about, are both related to in that double column, the sort of second and third from the right. Safe configuration is this question of can it be safely configured when it's not even trying to implement ECN? And the other one is to update the protocol themselves. And so since the last meeting, dealt with, or at least added, all these mobile IP protocols that use GRE as an encapsulation. They're effectively the control protocol, and you need to know what the control protocol is, because that determines the checking of the other end to check that it can support ECN before it puts ECN into the outer at the ingress. Because if it puts ECN into the outer at the ingress and the egress doesn't understand ECN at all, it will just all fall on the floor, and you get bad things happen. Then I mentioned Teredo last time. There's a little red cross there just to say I would have liked to put a change to the protocol in this RFC, which is what, or in this draft to become an RFC, which is what this draft is for. And I will try one more time to get that done before we go to working group last call. And the other one, Jay Collins helped me a lot with AMT. And we're putting an update into the protocol, and he's going to be implementing that. Then there was UDP tunneling generally, had missed out that rather important one, but there's already an RFC that covers that. And there was a really quite niche one with using TCP as an encapsulation for ICANN IPsec, which has, or at least now has, good text in it, and it's gone to RFC. So next.
Okay. So the diverse approximation, that slide is sort of a high pass filter on what is worth doing, which is what you're about to explain.
Yeah. Well, yeah. It's. I mean, that's the sort of initial grab of what there is to do. But then this explains why there's still some crosses in the column that says where the protocol needs to be updated and why it hasn't been. And that's largely based on human interaction. Where, first of all, you've got to find someone who maintains that protocol. I don't want to go changing an RFC when I don't really understand the protocol and the implications of changing it. And then if we get past those 2 points, I propose a fix, and like with Jake, it gets fixed, and we're done. Did the same with L2TP. But in some other cases, like the mobile IP ones, I get the feeling that it would be an academic exercise. It wouldn't really yeah, we might change the RFCs, but it's not going to change anything in real life. So, and there didn't seem to be the energy there to do it. So I'm, am I bothered?
This is likely one of those cases where IETF last call is helpful, as the other protocols you haven't thought about will come out of the woodwork then, and we can figure out what to do with them.
Well, that's why I'd rather it went earlier than
Yeah, okay, we'll move it.
Yeah, right. Okay. So the specific ones that have been updated this time round, we've updated them all anyway by putting a the safety clause in them, but we haven't actually updated the protocol unless we got someone interested. So, and the reason for putting the safety protocol in them all, or at least the safety guidance in, is that it puts an updates by flag on their RFC, so at least people know that there's something to do there, right?
And you know the bit which is going to get checked for at least the IESG and probably earlier, to make sure that anytime you update an RFC, somebody who cares about exactly that RFC can quickly find exactly what you changed.
Yes. Yeah. Right. So, as I said, AMT have now fixed that. That was quite an easy one because it's a unidirectional protocol. So it just needed a 1-bit flag coming from one end of the tunnel to tell the other end whether or not it would decapsulate ECN correctly. And that's been done, or at least been written. GRE put this safety clause in, but not dealt with any of the control protocols. And Sri Gundavali has been helping me with that, but I detect he won't want to go any further with that. Next. So, as I said, revision posted this morning, the original milestone. So, yeah, we're ready, but I'd quite like to get Teredo done at least, because I think that's important to get done.
Okay, so is this ready for working group last call?
It's the draft as it stands is ready now. Yes.
All right. I want to give it a sanity check, Reed, before I send it to working group last call. But
yeah.
I think getting it to working group last call before the end of November is reasonable.
Yeah. Regarding your question on whether it's changing making a load of other RFCs non-compliant, that's deliberately not the case. The safety thing, I've not said anything must about implementations. I've made it a must for operators to configure things correctly, so that it's not. And then there's a should.
I'll take a look.
Do your sanity check. Yeah.
Okay, while we're on that, the other working group last call question would be, is anybody willing to put their name forward now to read this and give us a review? When we come to call it, you don't have to do this today. You can promise in the future.
Thank you,
Stuart. Anyone else?
Quite like someone from Interior. Yeah, we've got.
Sure.
Yeah. Great.
Yeah, and of course, it might be with you, Bob, preparing a list of people who have contributed in some way.
It's all in the acknowledgements.
We will make sure that goes to the relevant areas saying, please review.
Yeah, I can give you that list. Yeah.
Also, both Corey and I have checked your emails. We can't find your slides. Please send them again.
Okay.
Okay, any questions for Bob? All right, I think we're done. All right, next up is round 1 of LEPHB. Okay, where are the slides? I don't know. All right, I'll go get them. Let me see if I can get them off the thing. Hang on a minute here. We'll see how fast this works.
Hi, I'm going to talk about the LEPHB as a chair. So I'll come over here to make running the slides a little bit easier. Roland's in the room if we have questions on the draft, but this isn't really about questions on the draft at the moment. What I'm going to do is try and just take through the discussion about the IANA registry and the choice of code point. Well, I don't want it that big. That is ridiculously huge.
Hang on. Something weird with the display. It's going to be a minute here.
My slides are in the proceedings. There's just a few slides. The first one's the name of the draft, which is on the side here. Okay. Okay, right, I will continue. The draft primarily concerns allocation of a code point to support lower effort traffic. Draft IETF TSVWG-20171113-1740. Next slide. Okay. The world as currently stands has tried to use CS1 to define a code point that can be used for sending traffic that's got a lower effort requirement than best effort. So this is basically scavenger class software update, background download, whatever you want to call it. However, this RFC doesn't actually allocate that code point, and that code point has some known problems. It has known problems when you try and do other things with diffserv because it doesn't really fit in, particularly the first few bits of the value 001, which we really don't want to have. If you want to follow that discussion, either come to the mic or look back in the proceedings to the last IETF where we discussed all this. So this is the place we're trying to get away from. This is the current IANA registry, and the current IANA registry has many items in there which are being used, many of which are deployed in networks. These are the well-known DSCPs. The only active pool currently in the IANA registry is Pool 1, and the proposal, as stated in Roland's draft and proposed to the working group in Prague, was we could use DSCP2. DSCP2 has the nice feature that the first 3 bits are all 0, which was one of the requirements for the work, and the last 3 bits are 0, 1, 0. Seemingly that was okay, apart from an issue with the idea that we're trying to define a lower effort PHP that can be deployed across the internet. So if we go to the next slide. The problem is some people out there who operate networks and configure routers and buy equipment don't actually change their configurations and their operational procedures every time the IETF tells them to. Amazingly, there are people out there who are still using the TOS precedence fields as their way of dealing with the diffserv code point, which means that there are devices out there which bleach the top 3 bits of a DSCP and mark it back to being 000. This is reasonably common practice among a small number of people doing it, but you might, in a particular survey, find 5%, 20% of packets remarked this way. Now, if this were just a issue within your own domain, that might not be in it, might not really be a problem because you can define and use CS1 as the US did with Internet 2. I mean, that worked. However, if we want to define something that works end-to-end, and I think that's the main purpose of things in TSVWG, we want a value that doesn't have a problem when there are mappings by real equipment. Now, this is particularly insidious because what happens with the TOS precedence bleaching action is that other traffic gets marked to the code point that we'd propose to use for a lower effort service. And it happens to be part of the AF class and unfortunately EF as well. So it really messes up the whole diffserv domain if you start then using DSCP2 for LE traffic. So let's move on. We talked about this, and I'll give you an option, because the option is the thing that we should be talking about, whether we want to do it or not. We spoke to IANA. We have another registry pool. We've currently only ever allocated from registry pool 1. It's reserved for standards action. Registry pool 2 is reserved for experimental or local use. We've got reason to believe operators have used these code points. They're assigned for them, and we expect them to continue to be assigned for them. But then there is pool 3. Pool 3, to our knowledge, has not been used for anything or standardized in any way. IANA controls the registry. There are no registry entries. The pool is currently being used for whatever purpose out there, and we assume that that purpose can change because the registry is marked for future standard action allocations as necessary. As necessary could be because we run out of pool 1 allocations, but we'd be willing, if this group thinks it's the right thing to do, to ask for IANA to open up that registry and start that process so that we can allocate a code point that has the top 3 bits set to 0, but also has the bottom 3 bits set to a value that doesn't have those mysterious effects that were discussed in Prague.
And we have to have a choice here between DSCP1 and DSCP5. I think the suggestion on the slide is DSCP1.
Yeah, both 1 and 5 would meet the criteria. If anyone knows any good reason why 1 shouldn't be used but 5 should be, then it would be good to know. If anyone has opinions, it would be really good to know. If anyone wants to comment in some way, that would be good. If you want to go and think, that would be good. But somehow out of this procedure, we're going to have to start asking our lovely area director and IANA to do something if the work wants to open up this new registry. Did that cover it, David, or do you want to ask me questions?
I think that covered it. As I said earlier, the goal of this time period, this time slot in the agenda, was not so much to make the decision, but to tee up what we're looking at and why we're looking at it, which is what Gori just described. I mean, if DSCP2 had been satisfactory across the board, we'd have probably had this draft at the RFC editor before Prague. It's not. There have been measurements reported that do show that this precedence bleaching occurs. I mean, as someone who worked on DiffServ, I was annoyed at DSCP bleaching. They bleached all 6 bits. Now that now looks like a feature by comparison to only bleaching the first 3. Any questions or comments on this? Be happy to take them in the hallway afterwards or during the week. The goal is to make a decision on this on Friday. And in fact, one of the sort of a nefarious agenda manipulations going on here is we tee the question up today and make a decision on Friday so people have time to think about it. Mr. Carpenter, sir.
The note taker has a question. Brian Carpenter. Is the mic on?
Yes, it is.
Okay, because there's not much feedback right here. Just an observation that one of the characteristics of Pool 3 is that it's defined as for local or experimental use. So we actually don't know if there is another category of operators who are using it for something because they're not obliged to tell anybody. So that's another thing to think about when thinking about opening up this pool.
And yes, please think about that. One of the things we might note, though, that if an operator's been using it, they may also understand how to remark DiffServ code points. And if they understand how to do that, they may then just bleach this traffic back to 0, which actually is not a disastrous outcome. What we don't want to do is end up with traffic allocated to the code point by accident. So bleaching all to 0 would be okay, and if that's what the operator action is, that would be all right as well. We really need people to think about this. Well, Bob.
Bob Briscoe, why do you say bleaching to 0 is okay for less than best effort?
Because the basic DiffServ community, the way in which DiffServ has been defined allows things to be effectively remarked to 0.
Yeah, on the assumption that will reduce their priority over that other traffic, but in this case, it will increase it.
Okay, and I think the RFC, as written by Roland, the RFC to be hopefully, as written by Roland, would have text in there that says that you should have a lead-back type or scavenger type transport running over this, so that even if you share with a bleached code point, you're okay. Now, not desirable, but okay. Right. What we don't want is the priority inversion where somebody's AF class, part of it gets mapped to this.
And much as it might be nice in principle to discard this on entry to a domain that doesn't understand it, the network does not need help from us in inventing new black holes.
Andrew McGrick at Google. We have a situation where we have a less than best effort code point allocated for our internal mappings. And there are many parts of the network where that code point and the default code point share a queue, and many parts where they do not. And the solution of using a less than best effort transport as well works just fine.
Okay, with that, I think we move on to the transport encryption draft. Are you presenting or is Colin presenting? Okay. Slides posted?
Slides are posted, and I presented something to try and tease people into reading this at the Ops security group, and we got feedback. So that was in the session prior to this. You can talk about your slides, and then we'll ask questions.
Okay, so is this working? Can you hear me? Anybody? Yeah? More up. Okay. All right, like this maybe. Okay, good. Hi, I'm Colin Perkins. I'm going to talk about the impact of transport header encryption on the operation and evolution of the internet. Next slide. So what we're seeing is increasing fractions of the transport headers being encrypted. And this is reducing the visibility of the various transport header fields, right? The sequence numbers, the acknowledgement numbers, the window, the flags in TCP, for example, are not visible in Quick. Maybe this is better. Yes, okay, good. So Quick is an example of this. We're seeing transport protocols making the choice to encrypt more of the headers, and it's not just Quick, it's a bunch of things, but Quick is perhaps the most active of them right now. And in principle, we could encrypt everything above the IP header and the ports, although so far no one has gone quite that far. Next slide. So there's obviously a bunch of good reasons for doing this. Right? A number of benefits people have mentioned. It reduces the information leakage from the transport layer, which makes it harder to infer the connection progress. It makes it harder to infer things like the round trip time, the timing variation. It prevents some spoofing and injection attacks, and just generally enhances the privacy of the connection, enhances the privacy of the transports. Equally, by encrypting, you stop the middle boxes looking at the packets, and that prevents the middle boxes sort of ossifying around a particular transport and gives you flexibility to change the transport protocol. And all these are good things, and they've all been widely reported. Next slide. What has perhaps been less widely discussed is that there are some costs to this as well. Right? There are costs in that by encrypting all of the transport headers, or a significant portion of the transport headers, we also complicate the network operations to some extent, and we complicate the process of specifying protocols and doing research and development on new protocols. Next slide. So in terms of network operations, obviously if the transport headers are observable, this lets the network operators analyze the performance of their network. Right? It lets them look at the behavior of the flows going through the network, detect anomalies, check to see that, and get some understanding of the mix of traffic in there, informs their traffic engineering, their capacity planning, and so on. And this gives them a sort of overall, passive view of the health of their network as a whole. It lets operators see what's going on. It lets them see if the network is behaving as they expect, because they can do broad high-level metrics for the understanding of the whole network across a range of flows. And they can spot when, for example, the latency spikes or packet loss starts happening by looking at the sequence numbers, looking at the round trip times and so on. And this, I'm not an operator, but from talking to the operators, I'm told that this is important to at least some of the operators. And if the headers, the transport headers start being encrypted, these operators are going to have to develop workarounds. And some of that might be statistical classification of the flows. Some of it might be active traffic probing in place of passive analysis. And some of it might be just encapsulating all the data inside some sort of shim layer, which replaces the headers we've encrypted at the transport layers. But people need this information. People are going to try and work around it if the headers are encrypted. In addition, when it comes to debugging, I mean, rather than thinking of the health of the overall health of the network, we also have to think about debugging particular problems with particular customers' networks, for example. And operators have the problem is they can't observe the transport behavior. It's very difficult to debug what's going on, right? If the headers are encrypted, then a flow which is being subject to packet loss, for example, is indistinguishable from any other flow because you can't see the sequence numbers and tell that there is packet loss happening. So in a world where a significant proportion of the transport headers are encrypted, debugging gets difficult. Right? Maybe we have to do active probes and run the risk that the active probe doesn't have the same characteristics of the traffic the user was using, and so behaves differently. Right? Maybe it's more intrusive. It might give you different answers. Or maybe you have to get the information from the endpoints about what the endpoint thinks the connection is doing after it's decrypted that information. And the question then is, do you trust that endpoint to be doing it correctly? Right? And sure, most of the time the endpoint will not be lying to the operator, but you don't know that, and you can't tell for sure unless you can see the transport headers. Okay, traffic analysis. Obviously, if you can't do traffic analysis, if you can't see the traffic you're analyzing. Next slide. I guess perhaps a sort of more philosophical point. If you encrypt the transport headers, the operators and people doing research on network protocols can't tell if the transports are behaving as they're expected. And we're sort of losing the information we need to inform future developments, to inform future standardization, because we don't know if the network is behaving, if the transport is behaving as we believe it is. And we've seen a number of presentations earlier in MapRG and ICCRG, for example, about problems with existing transports, and that these things happen all the time. And people can spot it because they can do measurements, they can analyze how the transport's behaving. And this is a sort of similar point. When we come to specifying the protocols, when we come to thinking about the feature interactions between different versions of the protocol, between protocols, we need to be able to see what's going on. Right? And yes, you can build a test bed, and you can set up a test bed that decrypts everything and logs the right information. And you can start to understand feature interactions that way. But to some extent, you have to do this in the wild to really understand the full range of behaviors that you see in the real network. Because when you put things out there on the real network, you find some weird pathology that no one had thought of. And again, that's difficult if the headers are encrypted. A final point, I think, relates to the way we build standards. Right? Clearly, being able to innovate faster is a good thing. We want to be able to change the transport protocols. We want to have a network which isn't ossified and lets us change things. However, we also need to avoid the problem where people build point solutions which don't get much review, work in the particular scenario they care about, but fail when deployed in other environments, other parts of the network. Because they're not robust, because they haven't seen wide review, because they have known what should be known problems which weren't spotted because the community couldn't review them. Right. TCP works well because it's had 25, 30 years, whatever it is, of open development and people looking at it and spotting the problems and proposing changes. Once we have pervasive encryption, once we have protocols that no one can see how they're behaving apart from the people building the endpoints, we lose some of those checks and balances because the community can't observe what's happening with the traffic and can't push back and say, that doesn't work right. Yeah. And that's a problem for the long-term health, I think, of the network and for the long-term health of the IETF, because it's reducing the sort of desire to work together to build the standards, because no one can see what's being deployed. So, we're not against transport level encryption, encrypting the transport headers, right? There are clearly some important benefits from doing this. I think what has perhaps been slightly lost, though, is that there are also costs. It has costs in terms of operations. It's got costs in terms of how we deploy protocols and how we build standards and how we do R&D on protocols. And we need to seek a balance. Right? We need to make sure that we're not obstructing real needs, which will just force people to deploy workarounds that take away the privacy benefits of encrypting it anyway. And if they do that, then there was no point in encrypting that information. So we'd like this to be considered as a working group item. Right? We'd like this to be considered as a working group item so we can get some discussion of these issues going. Right? As I say, we're not trying to say don't encrypt the transport headers. We're trying to say think about what is encrypted, think about the stakeholders here, and make sure that when you encrypt things, the privacy benefits outweigh the costs in terms of operations, R&D, standards development, and potentially privacy because people deploy more invasive monitoring mechanisms. Thank you. Any questions?
Yeah. Questions, comments?
Hey. Hello. Lars Eckert, I chair Quick. And this is obviously going to be a transport protocol that encrypts or has intended to encrypt as much as possible, and there's an ongoing discussion there also. So I'm wondering whether you think this document has anything to do with Quick.
I can't hear you very well, but do I think
sorry,
the document has anything to do
closer.
with Quick?
Lars Eckert, chair of Quick. Does this document have a relation to Quick?
I think Quick should be paying attention to some of these issues. Yes.
Do you think if this is adopted and there's consensus for these things in here, and this consensus is different than the consensus of the Quick Working Group, what should we do? So I'm asking specifically because for those of you who are not in Quick, right, there's a discussion on whether Quick should expose some limited amount of information about its operation, such as the RTT it's seeing in the clear. Whether that clear text is authenticated or not is up for discussion, but it would basically be observable but not necessarily changeable by the path. So that's a piece of information that sort of would restore some visibility into what Quick is doing that otherwise wouldn't be there. And there's an ongoing discussion that we're going to have on, well, we had a design team to figure out whether the operator community felt that there was a need for having this sort of information available. And spoiler alert, the design team is going to report on Wednesday that they didn't have consensus on an outcome. So there's going to be discussion on this on Wednesday. This seems to be an important discussion to have. However, Quick is on an extremely tight schedule.
Yes.
And we cannot wait for the transport area at its usual pace to answer this question in 5 years. What should we do?
I think Quick is on a very accelerated schedule, which is perhaps not taking input as broadly as it might. Now, what the chairs and the area directors decide to do, I think the IETF needs to have a discussion and come to a consensus on that.
Speaking
what happens
as,
for Quick, I will let the chairs figure it out.
So speaking as the uninvolved chair who's in the room, I certainly understand Lars's process concern, which is in particular, if Quick has these issues, Quick probably ought to be the first worked example. And using TSVWG to end run Quick and try to tell Quick what to do doesn't tend to end well. So I think I'd like to avoid that and basically suggest that step one is to focus attention on on these issues in quick and see where that goes.
I mean, this draft doesn't propose an outcome. It says we need to have the discussion.
Just to clarify, right? So I'm not concerned that this will be an end run to force a certain outcome. I'm concerned that quick will be blocked while nothing happens on this discussion, right? So we pushed the milestone for quick out by 6 months, and we've gotten an incredible amount of feedback from large implementers that this is very problematic and they really want to ship next year. And so the argument that's been made, and I'm not saying that this is the it's true, but it's been made several times, is that IETF quick getting delayed means that proprietary quick will see more deployment, which is not necessarily a bad thing, but it's not necessarily the outcome that the IETF would want to see, and so that's why there's a clock here.
But
there's
also been feedback from operators that is a problem to them.
I jumped to you to make the point that the danger I see is not the end run. The danger is the you can't put a quick RFC out while we don't have an answer here.
Let's get the AD to the mic.
Spencer Dawkins is the responsible area director, just so the next three people in line don't have to guess what I might be getting ready to say. Spencer's opinion about this is that this thing is targeting informational, and that it seems insane to hold up a working group on the outcome or the output of an informational draft in another working group. I'm not saying that that's never happened in the IETF, but it shouldn't happen here, it seems like to me. So I guess my question is, what is the intended argument for or intended audience for this if it turns out to not be quick? And people don't have to answer that question right now, but I hope people would think about it. I think that this is brilliant. I wish we'd been working on it all along, but we are where we are. So I'd like to make sure that if the brain power that goes into this, because the people who work on it are smart, if the brain power that goes into this is useful, that has an output that can be used someplace. That's I think the response. I think that's the responsibility of an area director to make sure that happens.
Hi, Brian Trammell. Let me first say, so as an editor of a quick document that actually tries to address a lot of the concerns that are in this document with a quick specific viewpoint, I really support having this document as a separate document, as a general sort of principles of these are the things focused directly on the transport layer. So this is not the only document that is being discussed in the IETF right now that touches this same issue. We're kind of, as an organization, spinning our wheels on it. And I think that this approach to it, by looking specifically at a narrower impact on more or less the people in this room, is one possible way to maybe get a little bit further down the pike. As one of the editors of the manageability draft in Quick, I think we, regardless of what happens with this draft here, I would support its adoption here and bringing it into the working group. Regardless of its status here, I think we need to sync up and make sure that the insights here get into the management draft in Quick.
Sure.
I'm sure there's a whole list of other drafts that touch on various other aspects of this, and I'm assuming that you've at least skimmed all of them, and that you've taken the things from those that are relevant, and you've ignored the things from those that are not relevant.
I believe so, although I'm sure we've missed something.
Okay, cool.
So Gary coming over this side of the room and trying to sound a sensible volume level. Yeah, we've looked at many, but if you know of more, that's always good. One thing in particular is the one that Al Morton and Kathleen Moriarty is in IETF last call at the moment, and that looks at operational viewpoints of various stories about things that are going on in the operations world. So if people are interested in this subject, that's definitely one to make comment on the IETF list.
Yeah, I think that to reiterate, I think that this is absolutely the right way to try and tackle this problem, is to try and bring it in here, and I hope we adopt it.
Fleming Andreasen. So first of all, thank you for doing this work. I very much agree with the message that you're trying to send here, which is that we need more balance in this debate. We all understand the privacy and security issues, and we agree that they need to be addressed. But it seems like we've moved a little bit too far in that direction, and we're not adequately taking into consideration what are the implications of that. So I am very supportive of both the message and the intent here. So I would like to see this work move forward. I think some good questions have been brought up in terms of more concretely, what does that mean? But I think for starters, if we can get on a page where everybody recognizes that these issues need to be addressed as well, then at least we're off to a good start, because the debate tends to go too much in one direction right now, in my experience at least.
Could you say your name again a little more slowly and clearly for the minute takers to grab it?
Fleming Andreasen.
Ronnie Evan. I think I support this document. I think it's important because currently there is a BCP 101 that says that network might, even though security is the important, I mean, network need to be manageable, but it doesn't say what it means to be manageable. I think this thing says what is needed in order for the network to be managed, and that's why I think it's important, because it's complement this IAB document, and I think that should be considered for every transport that we are doing now.
Okay. And again, name a little more slowly and distinctly for the minute takers, please. I apologize.
Ronnie Evan.
Ronnie, thank you.
Joey Egley. So I'm largely sympathetic to the vantage point where in systems need to be protected from meddling of middle boxes on the network itself, and the depredations of outside observation. One of the problems I also have, of course, is that I actually have to protect endpoints in ways that are sufficiently scalable that they don't happen to get wiped off the map by large collections of devices that may or may not wish to reveal their intentions before sending me a packet. But I think one of the things that is sort of poorly explored in our understanding of why people want visibility or control in transports is the question of the integrity of the material that's within them. So some of the biggest problems we have are when people design middle boxes that manipulate the stuff without necessarily disclosing that they're doing that. And I think that actually is because for things where we wanted to provide visibility, we didn't provide enough protection for integrity where that was actually a required feature as well. So for example, NAT translators are enabled by the fact that you can manipulate the source ports or destination ports for that matter without any significant effort, like encapsulation, for example. You can simply rewrite the packet because those things are not protected in any cryptographically significant way. I'd still like to know what a flow is. That doesn't mean that I necessarily want middle boxes to be able to change elements of that. And I think integrity protection, particularly cryptographic integrity protection, is an important component of allowing for visibility, because that way, if I have to expose certain information from a network management vantage point, I still want to know that it hasn't been messed with
at this point. So,
and I think that is actually a place that's sort of poorly explored
Yes, I very much agree that we've not really explored that part of the space very much. Yeah.
Lars, not speaking as quick trade this time. And following up to what Joel said, so integrity protection is certainly, it's not controversial, really, I think, that we should, integrity protection is, I think, not controversial. And so Fleming painted a picture that this is, privacy versus operations. It's actually not, or not only, right? Privacy is certainly one aspect, but there's also the aspect of, even if you integrity protect transport level information, middle boxes are going to ossify around what they see, and we want to be able to change that. And we can't if it's in the clear, because stuff will be shipped that thinks this field is always this, and if it's not anymore, it'll go wrong. That's the harder problem. Well, it's also a hard problem. Like privacy, I don't understand very deeply, so I'm not going to comment on it. But once you expose it, right, it is actually going to be used. And when we roll a new version of QuickWin, we're going to be rolling them frequently, and we're going to those bits are going to have something else in them. The middle boxes are not necessarily going to know what to do with that for very long. Either you're going to update them, a lot, or you're going to have a middle box that's not very useful. And we're doing this because what we found with TCP is that there is enough old crap out there that actually breaks TCP and makes it slower these days, right? So V6 is faster than V4, mostly because there's not so much crap in the path. And encrypting everything is a way to not allow crap to have anything to grab on. And that's an argument, I think, that resonates with me personally. And I would love to hear from operators that come and say, when we're doing this, we have a very limited need for a piece of information. This is something that, has consensus to be good to expose or helpful to expose. I personally haven't really seen it yet, but those sorts of things are interesting, because otherwise, I fully subscribe to your point, right? I have a research hat that I occasionally use for stuff, and it's nice to be able to see stuff and measure stuff, and it helps us learn things about the network. But that same information makes the network ossify.
Yes, and I think the trade-off, which is perhaps not as widely discussed as it should be, is whether that ossification is a good thing or a bad thing. And in some ways, it's clearly a bad thing because it stops us changing things. In other ways, it's a good thing because it stops us changing things. And it means we have been successful and the stuff is out there and being used and people are building on it.
Okay.
So we need to decide carefully what we expose and what we allow to be ossified and what we allow to change. We haven't thought that through very cleanly.
Mark Townsley from Cisco. I think that the current cat and mouse game between the endpoints and the network elements, endpoints hide from the network elements do more and more things to discover the endpoints. Even if everything's encrypted, we'll analyze the flows, apply signature databases, machine learning, you name it, to figure out what's going on there because our operators, our customers demand it, right? So this is a race to the bottom. If we can step back and with some very thoughtful analysis and just as importantly, understanding and sort of trust in terms of what can be exposed to make things better, it can stop that. So I fully respect Lars's point here, but don't think that the only way.
Sorry.
Sorry?
I'm going to say, but Mark, you're the last speaker on this draft.
Okay. Don't think that the only way you can ossify a protocol with network elements is through clear text. So
I suspect there are going to be some.
I'd rather
very
step
subtle...
back, stop the race to the bottom, and try to figure out, the right way to expose the data for the right things. And I know that's hard, but if we can't do it, who else can?
Yes, I think we. I think we run the risk of having some very obscure statistical or machine learning classifiers ossifying the network, and I'm not sure I want to go there. It may be unavoidable. But.
I won't entertain that anyway.
Okay. Where are the blue sheets? And raise your hand if you haven't signed the blue sheets. I think we'll have them up front afterwards. All right. At this point, I think we are now well over time, so we're not going to get to the priority scheduling draft. We'll see everybody on Friday. What was that? We're far enough over. I mean, we started 5 late. We ran at least an hour 5. Okay.